Hello everybody. So today I want to look again at unit vectors and look at them inside of Houdini. Now this has been quite a difficult tutorial for me to actually explain it, as I was struggling a little bit with the mathematics myself. I'm no mathematician at all, so I'm sure you guys can come up with better solutions or examples to this. But I wanted to show you how to normalize a vector. Normalizing the vector inside of Houdini basically creates a length of 1, which will then class as a unit vector, as we saw in the previous lesson, when the length, magnitude is 1 of that vector. So let's start by taking a look at a simple example. I want to start with a grid, and within this grid, let me just put on these parts. There we go, so I can see the geometry better. And I want to create the size 1, 1, I think. Let's zoom into that. And the rows and columns, there we go. And let's maybe move this to the side. All right. And we can see that here we've got something sticking out here, which is the vertices. I've actually got turned on here. If you look at this thing here, it says display normals. I'm going to create those normals on the points. So let's just use the normal node and move this to points. There we go. They'll see that they'll change blue and they're now directly on the point, which is cool. But I want them to display outwards, okay, so like at a diagonal direction. And the way to do this, my easiest way anyway, is to use something called an attribute Wrangle, and it's using a little bit of vex code. And we've looked at a little bit of vex already, but I'll make this as simple as I can for you. So what I want to do is I need a vector, and I'm looking at the normals, right? And I want them this time to go with the position. And there we see that they now pop out in a diagonal direction. The reason for that, of course, is that the direction here is minus 0.5, minus 0.5, etc. You see the position attribute just right here, and you'll see that the normal will match that, right? To display this normal, you can see it's now pointing in this direction. I want to display it at the full 1 unit, so hit D, go into your display options. You'll see if you go under this markers, it will probably come up as, go to guides, it'll say scale normal 0.2. You want to change that to 1, then you can see it at its full length. Okay. Now looking at that, I think, okay, that's really great. However, I want to make that normal a length of simply 1. Now how can I do that? And the way to do that is that I'm just going to normalize this. So I'm going to put that in brackets, and I'm going to normalize, use the normalize function for this. And now I can see that they increased in length a little bit when I did that. And notice though that it doesn't say it's a length of 1. It actually has this number, which is 0.707107, and you're like, whoa, where did that number come from? Now the reason being, of course, is that while this is a length of 1, if I had it pointing, say, horizontally or vertically, I would get a 1 here. But because it's going diagonally, of course, it's not reaching to that 1, 1 position. It just reaches to a part of that. Another way to demonstrate this, and to try and make this maybe a bit more clear, is maybe if I had let's try it with a sphere, and I want to have let's just create a regular sphere. Just thinking on my feet a little bit here. All right, I might turn this off a moment, and let's make this a NURB sphere, I think, and I can cut this. All right, happy days. And what I now want to do is create a line. So I'm just going to create, let's add a point, just add 1 point first of all. There we go. And then I'm going to add another point. And this time I'm going to put it, let me see where we were here. So yeah, it's in Y and Z. So let's do the same thing here. So in Y I'll put it to 1, in Z I'll put it to 1, right? And now I've got these 2 points, but yeah, don't forget to make it into a line. And I do that by group, there we go. Now I've got myself the line that I want, brilliant. Now I can see also that my sphere has a radius of, let me see what it is, a radius of 0.5. I want this to have a radius of 1. So let's make that slightly bigger. Okay. And I also want to know what is the measurement of, let's go to measure, the measurement of this line. Remember that a unit vector will have a line measurement of 1. But we can see here that if this sphere has a radius of 1, it would cut off, my line would cut off here. And I'm using this line as an example of my vector. Okay. Now if I go into the measurement and I want to find out what the length of that is, let's go to this one and into my parameter here. My parameter says it's 0.41, etc. right? So I know that this length is longer because, of course, it's while it's at 1, 1. Let me find that, go back to my points. While this is in 0, 1, 1 as my vector, I can also see that the measurement, of course, is longer because of that direction. Now, so how do I make this shorter? Well, the way to make this shorter here will be, I will use a curve intersect. Let's use that one. And let's add these together and pop that there. And now I see a little dot that's popped up right at the position where it intersects directly with the sphere. I want to, let's remove that. And let's this time go to... this will keep none, and okay. So if I go into left face pieces, I can choose whether to keep the inner part, which is the odd number, the outer part, which is the even number, or keep none, which keeps nothing, right? But in this case, we want this line here, and I can see now that let me just turn that. Okay, I can see now that my line here should be a length of 1, I hope. Now it's been cut. So let's go to my measure node just to check that it's now exactly 1. And let's go there. Oops. Let's also create the length. Okay, now it's a length of 1. Okay, brilliant. But look what happens when I go into my points and I will see the position of this. Now the position is now 0.707107, and if I look back here, I have exactly the same. So I know that my normal have been normalized. I've created a unit vector, and this creates the length of 1. I just wanted to show you in case it was confusing when you look at that and you go, oh, hold on, this isn't 1. Of course it's not, because the position and the diagonal movement of that, well, it's still a length of 1, but the position of the actual points themselves will not be at 1 unless it's just going in one direction, of course. I hope that makes sense. That was really hard for me to even understand myself, but I wanted to give you 2 examples where you can actually see that the numbers match. Let me put the normals back on, where you can see that the numbers match, and then that would make hopefully some sense to you. I hope so. This is more of just a reference video, I guess. You don't need to actually do anything inside of your computer for this, but I just wanted to show you an example of how these unit vectors work. So when I'm trying to normalize a vector, in my examples I tend to use the vex code. There are other ways to do it too, but when I'm explaining these, I'm just going to simply use vex code because that's for me the easiest way, and this code here is actually pretty straightforward as far as vex goes. Of course, if you have any questions or queries or comments or criticisms, please ask away. I will try my best to get my head around this and explain it better if need be. Or if any of you have any better examples, please feel free to show them or explain them, and I'll be happy to go along with that too. Okay, so good luck guys, and I will speak to you soon. All right, bye bye.